Hi, welcome back to 5.6. In this video, we're going to look at example 2. We are going to model the angle of the sun above the horizon on the summer solstice in Inuvik. So the table shows the angle of the sun above the horizon for each hour on the summer solstice in Inuvik, Northwest Territories. So here is our data of all that information. So it says, part A, use a table to determine a sinusoidal model for the angle of the sun above the horizon. So we want a function that's going to be the angle versus the number of hours or the time past midnight. Okay, so what I've done here is I put a few things into Desmos. This is an old graph there. We'll turn that off. I've entered in all the table of values here. So I'm going to turn that scatter plot on. We'll adjust this window. Okay, there's all the points that I entered in previously. And we can see we kind of have like a nice sine function. So I would like to come up with an equation to model this. So we're going to follow the same, basically the same things that we did last time. We're going to look at a minimum and maximum value. So let's circle those on the graph first. So I'm scanning my entries right here. This is the angle above the horizon. So a minimum value, I think it's 1.8. Yeah, that's the small set of all those, so 1.8. So this is our minimum. So the minimum happens at month 1, and the maximum, I see 46. I think that's the maximum. That's actually right here. Makes sense. This is hour 1 and this is hour 13. So it's exactly 12 hours apart to go from max to min. So it looks like we'll probably have a period of a full 24 hours. Okay, so let's go ahead. Let's kind of get to it. We're gonna try to come up with our amplitude first. So the amplitude is equal to max minus min over 2. So 46 minus 1.8 over 2. It's going to be 44.2 over 2, which is 22.1. So that's my value for A. Okay, we're kind of getting our equation started here. The center line C, that's always the middle value. So what I do is I just add the max and min together and divide by 2, so it finds the average. 46 plus 1.8 over 2. That's 47.8 over 2, which is 43.4. Okay, let me double check that. 47.8, I think it's actually a little bit more. Divide by 2. Oh yeah, I don't know what I was thinking there. Yeah, that's 23.9. Okay, that makes a lot more sense. Okay, so therefore C is equal to 23.9. All right, and our K value. So K is going to be 360 over the period. And our period is, so for one full cycle, it makes sense that, tracking the angle of the sun, that it's going to repeat every full day, every 24 hours, right? We can actually see that looking at the graph. Okay, that 24 hours would be one full cycle. We can tell also from looking at the table at 0, or actually even, 0, we're at 2.4, almost a minimum. And then at 23, we're almost back at a minimum again. So you imagine that if there was one more hour, we would probably be back at this value here. So definitely 24 hours for one full cycle. So 360 divided by 24 should give us 15. Yeah, we got 15. Okay, the next thing I'll need to look for is the phase shift. So speaking with you guys in class, I know sometimes you kind of like to draw the graph first and then try to find a phase shift. So I'm actually not going to use, does it say to use a sine function? This is sinusoidal, so I can use cos for this, which I will. Okay, I'm using cos because it looks like my graph is starting at a minimum. Okay, and all I have to do is make the amplitude negative. Okay, so say starts near minimum. So that's a good reason to use the cos. Okay, there will be a phase shift, so we'll say the hour is going to be time. Okay. So, and actually, instead of using y, I probably should use a different variable for the angle above the horizon. I'm just going to use capital A for angle. All right, there will be a phase shift, and I can tell by the graph that it's going to be 1 month. I can see the minimum happens at the first hour, so I should be shifting this over 1. And then my center line is at 23.9. Okay, so if you remember here, the minimum in our table happened at hour 1. So if I don't do a phase shift in this graph, then that's going to have a minimum that's going to start at hour 0, which is wrong. We want to move it over 1 month. That's why we have a phase shift of 1. Let's enter in our graph and see what we get. Negative 22.1, cos 15, then we'll say x. I'm going to add the phase shift after, just so we can see how that works. 23.9. So you see I have everything in except for the phase shift. Notice my minimum is happening at 0 on the y-axis, and that's incorrect. It should be happening at hour 1, the minimum. So it just needs to bump over 1 to the right. So we write minus 1. Okay, and then it's almost perfect. Okay, I would move it over a little bit more, but it looks like after like the maximum, the points are on the other side. So I'm just going to keep it like that. So it's actually a pretty good fit. Okay, so there's our equation. Leave it like that. Okay, just to show a few things too, if I wouldn't have had that negative sign on the amplitude, I would have been beginning at a maximum, which we know would be wrong. That's why that negative is there. Okay, so that's it. That's my equation that's going to work. Let's look at part B. It says graph the points in the table on the same set of axes as your model to verify the fit. So we actually have done that already. And then part C is the fit as expected. Explain any discrepancies. So I think the fit is really good. So the only thing I could maybe say is that as the day begins, it looks like our model starts to pull away a bit, and then it's good as the day ends up here, but then it starts to pull away again as the day ends. So also, I'm not sure about the period either. Looking at this, our period might be a little bit off. Maybe it might not be exactly 24 hours either. So there's just maybe a couple of discrepancies. So we'll write that in here. We'll say C, the fit is good. Okay. The model pulls away a bit. during, we can say as the day progresses, the model pulls away a bit as the day progresses. Okay, also the period may not be exactly 24 hours. So you might want to argue with me about that too, maybe. You might say, okay, how is like the daylight, the period not 24 hours? Well, it has to do with the Earth being on its axis, a tilted axis, and then being up north near the North Pole. The daylight hours aren't going to be exactly 24 hours as the Earth rotates around. So um, that's why there might be a slight discrepancy. Okay, all right, so that is it for example 2. See you guys in the next video.